In this video, we're going to calculate some indefinite integrals using u substitution. And I'll talk a little bit how I'm choosing my u. So, looking at a here, what I notice is I've got a 5x cubed plus 1 in the denominator and an x squared in the numerator. Remember, your choice of u must have its derivative in there, give or take a constant. So that tells me that I'm probably going to want to let my u be the whole denominator, 5x cubed plus 1, because then my du, which I just calculate the derivative here, is 15x squared dx. Now, I already have the x squared dx in there. The 15 I can put in, because I can put a 15 here, and I can balance that out with a 1/15 out here. Now I've got a nice substitution, because I'm going to have 1/15. The denominator is just going to be u, because that's what we let it be. And right there, the 15x squared dx is my du. So if you want, you can write it du over u or 1 over u du, whatever you like better. Well, we now have a basic antiderivative. The antiderivative of ln of 1 over u is natural log of absolute value of u plus c. And last step in u substitution is of an indefinite integral is you got to substitute back. Ln of the absolute value of 5x cubed plus 1 plus c. So there, we just plug that back in for u. Let's take a look at the next one. Again, I need to make a choice such that its derivative's in there and it's going to make this thing simpler. Remember, one of the nice properties about e to the x is it is its own derivative. So look at what happens. If I let u equal e to the x, then my du is the derivative of that, which is e to the x dx. I have exactly e to the x dx already in there. So this is going to be the antiderivative of sine of u, and then e to the x dx is my du, and I get actually a pretty nice little neat integral. Which will be negative cosine of u plus c. And substituting back, we get negative cosine of e to the x plus c. Now, I'm not doing it in this video for time's sake, but normally what we would do is as you're learning u substitution, what you do after you get your antiderivative, take its derivative and make sure you get back to where you started. What you'd see is that via the chain rule, when we do the derivative of the inside, that's what's going to put that e to the x out front. C is kind of a tricky one the first time you see it. But what we know is that square root of x is what's causing the problem. So let's say, okay, let u equal square root of x. Now, one of the things I'll see happen is people will put u in for both of these. That doesn't really improve your situation. Now check this out. Remember that this is x to the 1/2. So the derivative of du is 1/2 x to the minus 1/2 dx. Or, putting it back in terms of a radical, that's 1 over 2 square root of x dx. There's where that other square root of x is going to come from. Now I need a 2 in here, so I'm going to put a 2 out here. Those 2's cancel, so I didn't change anything, but now there's my 1 over 2 square root of x dx, and I now have my substitution. So 2 cosine of u, and then there's my du, and we get actually a really easy antiderivative, which is just 2 sine of u plus c. And we substitute back, we get 2 sine of the square root of x plus c. So probably good practice is to go ahead and take that derivative. It's good work on your chain rule anyways, and make sure we get back to where we started.